Why Earth refused to stay frozen forever. There was a time when the planet nearly locked itself in ice. Oceans froze, continents vanished beneath snow, and sunlight barely mattered. Yet somehow, Earth pulled itself back from the edge. Frozen worlds are common in the universe, and once a planet falls into permanent ice, escape is rare. This matters because Earth came dangerously close to becoming one of them. Long after oceans formed and continents stabilized, the planet entered extreme cold phases that should have ended surface activity entirely. What saved Earth was not chance alone, but a balance between forces that refused to shut down. The difference between a frozen grave and a living world came down to processes buried so deep beneath the ice that no surface observer could have known they were still working. As continents grew and weathering intensified, carbon dioxide was steadily pulled from the atmosphere and locked into rock. This process cooled the planet efficiently, but too efficiently. Temperatures dropped, ice expanded, and sunlight reflected back into space instead of warming the surface. The colder Earth became, the easier it was for ice to spread even further. Each degree of cooling made the next degree easier to reach, and the planet began sliding toward a state from which recovery seemed impossible. Eventually, glaciers reached the equator. Oceans sealed beneath thick ice. Weather nearly stopped. From space, Earth would have appeared pale and silent, a frozen sphere drifting through sunlight it could no longer use. Life, if it existed at all, was forced into isolated refuges beneath ice and water, clinging to energy sources that did not depend on the sun. But the planet never became truly still. Beneath the frozen surface, internal heat continued to rise. Volcanoes erupted through ice and ocean alike, releasing gases into an atmosphere that could no longer remove them efficiently. Carbon dioxide began to accumulate again, slowly rebuilding the greenhouse effect that ice had suppressed. This accumulation was invisible from the surface, but it was relentless, driven by forces that ice could not reach or restrain. Earth was frozen on the outside, but restless within, and that tension would not remain unresolved. As the ice tightened its grip, the planet entered a dangerous feedback loop where cold reinforced itself at every turn. Ice reflected sunlight, cooling the surface further, which allowed more ice to form and spread. Oceans trapped beneath thick frozen shells could no longer exchange gases with the atmosphere, cutting off many of the processes that once regulated temperature. From the surface, Earth appeared locked into permanence. The planet had become a mirror, turning away the very energy it needed to survive. Yet deep below, the planet never stopped working. Tectonic plates continued to move, driven by heat that ice could not touch. Volcanoes released carbon dioxide steadily into the atmosphere, but with weathering nearly halted, there was no efficient way to remove it. The gas accumulated slowly, year after year, century after century, rebuilding pressure in the sky above the ice. This was the same carbon cycle that had once cooled the planet, now working in reverse, storing warmth in an atmosphere that had no way to shed it. This imbalance grew quietly. Sunlight still arrived, faint but persistent, and the thickening atmosphere began trapping more of that energy instead of reflecting it away. Temperatures crept upward almost imperceptibly at first, too slowly to be noticed by anything that might have been watching. But once a threshold was crossed, the system shifted rapidly. The feedback loop that had locked Earth in ice now began to dismantle itself with equal force. Ice near the equator began to thin. Darker surfaces emerged, absorbing more heat and accelerating the melt. Water flowed again, carrying heat and reshaping the surface beneath the retreating ice. What had taken millions of years to freeze began to unravel far more quickly. The speed of the reversal was itself a testament to the power of the forces that had been building unseen beneath the frozen shell. Earth was not rescued by a single event. It escaped because its systems never stopped pushing back. The same forces that allowed the planet to freeze also ensured that it could not remain frozen forever. The balance had tipped, and the return from ice would be just as dramatic as the fall into it. As the ice retreated, the planet entered a period of extreme transition, where stability returned faster than ecosystems could adapt. Meltwater surged across the continents, carving vast channels and flooding lowlands that had been buried beneath ice for ages beyond memory. Oceans reopened to the atmosphere, releasing trapped gases and redistributing heat across the globe in powerful new circulation patterns. The surface transformed rapidly, and environments that had been sealed for millions of years were suddenly exposed to warmth and light. This rapid warming carried its own dangers. Greenhouse gases that had accumulated during the frozen era now flooded the atmosphere all at once, pushing temperatures higher than they had been before the planet froze. Earth swung from one extreme to the other, testing whether its recovery mechanisms could prevent collapse in the opposite direction. Ice vanished, but balance had not yet returned. The planet faced a risk of overshooting into runaway heat, trading one crisis for another without pause. Weathering resumed with renewed intensity. Rain fell on freshly exposed rock, pulling carbon dioxide from the air and slowly restoring equilibrium. Rivers carried minerals into the oceans, fueling biological activity that would soon begin reshaping the atmosphere itself. Each cycle worked against excess, dampening the extremes that had nearly ended surface life. The very process that had overcooled the planet was now pulling it back from overheating, demonstrating the remarkable symmetry of Earth's self-correcting systems. This build-up toward equilibrium revealed the planet's most important trait. Earth did not seek a single stable state. It oscillated, overshot, corrected, and adapted. Its survival depended not on avoiding extremes, but on having systems capable of pulling it back when those extremes arrived. The frozen world had not been a failure. It was a test, and by surviving it, Earth proved that it could recover even from its own worst conditions. The ice had released its grip, but the consequences of that escape were only beginning to unfold. The climax of Earth's frozen chapter was not the melting itself, but what survived it. Life endured beneath ice. Chemistry continued in the dark, and internal systems never shut down. When warmth returned, the planet did not need to start over. It resumed. That distinction changed everything. The thread of complexity had not been severed, only stretched thin, and when conditions improved, it thickened again with a speed that proved how much had been preserved through the worst of it. As oceans reopened and continents thawed, Earth entered a new phase of opportunity. Nutrients released by glaciers flooded the seas, triggering bursts of biological activity that reshaped ecosystems and altered the atmosphere. The planet did not simply recover from ice. It evolved because of it. Extremes had forced innovation, and survival had rewarded adaptability. The resolution lies in what this cycle revealed about Earth's nature. The planet is not stable because it avoids danger. It is stable because it can move through danger without breaking its core systems. Ice nearly ended surface life, but it also strengthened the feedback loops that regulate climate to this day. This lesson remains deeply relevant. Earth's history shows that change is unavoidable, but outcomes are not predetermined. Recovery depends on balance, timing, and the quiet persistence of systems working beneath the surface long before results become visible. Earth refused to stay frozen because it never stopped responding. And that resilience, forged over billions of years, is the reason this world remains alive now. Subscribe to join the journey. Why?